Okay, so now we got all these things. Now let's move on to, we are still on the design of the chassis frame structure only. Okay, strength and stiffness. Stiffness depends on the geometry. I am not saying it only depends on the geometry, but yes, the geometry of your chassis frame structure actually decides the stiffness of your frame. Yesterday we were discussing, and I told you, like, whenever we ask anyone, what do you want in your chassis frame structure? Like, what do you want a chassis frame structure to be? And they said, we want our chassis frame structure to have very high strength. Is it true? We need a very high strength, that's absolutely fine, but we need a very good stiffness too. I'm not saying that we need the very high stiffness or a very low stiffness, but there would be some optimum value as per your performance criteria. Maybe you need the bit of flex in your vehicle, or maybe you don't need even a fraction of a very minimum value of the stiffness. Maybe you just need to make a very brittle chassis frame structure, very stiff chassis frame structure, or maybe you want to make a less stiffer chassis frame structure for the comfort, or maybe for some other your performance criteria. Now, what is the difference between the strength and stiffness? What is the difference between the strength and stiffness? So now, if I say, I know already, like most of you already know about this thing, not most of you, almost every one of you knows about it. Like if you are an engineering student, everyone knows the difference between strength and stiffness. But then also I just want to give it a bit of understanding, because it's very important for us to know this thing. There should be no doubt left when we talk about the strength or stiffness or the inertia, the movements, or any of the equations when you are dealing with. Strength and the stiffness. If I start with the stiffness, if I take any rope or I take any wire, here in my room, if I have got any wire or the rope. Now, if you see this wire, the strength of this wire is bit high, right? See, it's bit high. I won't be able to like just cripple it down. It's not possible for me right now, right? The strength of this wire is very high. But what about its stiffness? See, if I drop it, the stiffness of this wire is very less. But its strength is very high. You got the clear-cut understanding what's the difference between strength and stiffness? The strength of this wire is very high, while the stiffness of this wire is very low. Similarly, if I take an example of something else, take the example of now, and if I take the example of this biscuit, see, its stiffness is very high, but its strength is very less. In the case of wire, the strength is very high, but the stiffness is very less, right? But in this case, the strength is very less, but the stiffness is very high. You got the clear understanding? So there are two types of frames. Either you have to make it stiffer, or you have to make it having a very high strength with a lesser stiffness, or you can make a matrix out of it. Strength and stiffness matrix on different values. You can make the matrix of stiffness and strength of your chassis frame. Now, your strength of the material increases. If we increase the mass of material. The strength of the material increases if we increase the mass of material, while the stiffness depends on the geometry. It also depends on the geometry. Again, I am taking the example of biscuit. See, this is the biscuit. I applied a bit of load here. Basically, I have to apply like this, should be held like this, and I should have to apply load like this. See, it broke. What if I have the biscuit in this direction? Now I have to apply the same load. Is it breaking? No, it's not breaking. Why? Because the area moment of inertia along this axis has been increased tremendously. The area moment of inertia along this axis has been increased tremendously. So you got this idea, very clear cut idea. Taking the example of this parle-g, if I apply the load, it will break in this. If I apply a load like this, it won't break. Area moment of inertia, yes, area moment of inertia. Again, with the pens, if both are having the same weight, if I start to twist it, it won't twist. The angle of twisting in this marker would be very less in comparison to the angle of twist in this marker having the lesser cross section area. You got this thing? Your geometry of the chassis frame structure is very, very, very important. Now there is one more term. Let's go with that also. Now, when anyone asks you about the stiffness, what is the stiffness? Like, it's very easy for you to say, sir, force, whatever the forces that I am applying and the deformation that I have got. Like delta, the delta I am denoting the deformation. That is Newton per millimeter. Okay, very good. This could be your deformation, or I could say the stresses and the deformation, like multiplication of that, the vector form of that. Okay, that could be the deformation. Or what if I will ask you about the bending stiffness? Bending stiffness. The material stiffness, the bending stiffness, the structural stiffness are different, right? The material that I am using, so it's been recommended to use the materials having the higher cross section. I'm not talking about increasing the weight, I'm talking about increasing the cross section. If you increase the cross section for individual material, for individual member, not the material, sorry, for the individual member, your bending strength of the material will increase. Because when you talk about the bending stiffness, you won't consider the mass, but you will consider the inertia. Which inertia? Area moment of inertia. When I talk about the bending stiffness of an object or the bending stiffness of a member, for the bending stiffness of a member, the area moment of inertia should have to be considered, right? So if I am having, like, I am manufacturing a chassis frame structure, a space frame chassis frame structure. Okay, before getting into this, let's talk about the space frame structure. What do you mean by space frame structure? Yesterday, I told you about the ladder frame and I asked you all to read about this thing. What are the drawbacks of a ladder frame structure? Okay. Two longitudinal run members, or I would better draw this diagram here so that I can get all the three diagrams together. Ladder frame structure. From the ladder frame structure only, all the other chassis frames have been derived. Now I am just giving it the modification of the ladder frame structure so that we can get into the space frame structure. From the ladder frame structure, we have got the backbone structure. Let me refill the marker. Okay, so now this is the ladder frame structure. Now after the ladder frame, I have got the backbone structure too, which is of no relevance for us. Then if I modify this backbone structure, this ladder frame structure, now you can see this is a 2D diagram only. One member, two longitudinal members. There could be n number of lateral members, right? N number of lateral members. But only two longitudinal members. What if I will have four longitudinal members? Two here, two here, and above this plane, yes, here base frame, and above the base frame also, if I am going to have some members, similar, you can call it a box. Two members, right? I can call it a box. See, one longitudinal member, this one longitudinal member, one longitudinal member, one longitudinal member, one longitudinal member. You got this thing, right? Okay. And then The lateral members. The lateral members. You will find all the members are lateral and longitudinal. Lateral and longitudinal. Also known as box design. This is ladder frame design, box frame design. Ladder frame design. And then again there is a space frame structure which is made up on the principles of truss, or better you call it the triangulation. Please search the space frame structure, please search the space frame structure, or better you search the design of a supra. You will get a very good structure, a very good implication to learn about the trusses, the triangulation, or the space frame structure. I told you I am very bad with the arts or with the drawing, so I won't be able to draw it here. The difference between the space frame structure, like in the space frame structure, you will find many of the triangulated members. Like see, are triangulated members. In the space frame structure, you will find many of the triangulated members, and these triangulated members with the space frame structure, there is a difference between the space frame structure and the box frame structure. In the box frame structure, the members are in bending load. There is a bending force acting on your box frame design, or it is sustaining the bending loads, or what I could say, like it is always being acted upon by the bending loads. See, the bending loads. But what if I am going to have the triangulated members here? There is a difference between the space frame and the box frame design, that in the space frame all the members are in tension or in compression. Yes, the same that you have studied in truss or in the triangulation theorem. So your space frame structure has been made up of, or is being triangulated, or is made up of trusses. Now in the ladder frame structure, if any of the torsion is being applied, just consider my vehicle is taking a very hard corner, here and here I have got all the forces acting. What will happen? At this case you will find the maximum twist. While in this case, because there are more of the masses accompanied inside it, there would be somewhat lesser twist. But in this frame, if you have specifically designed a very good space frame structure, ladder frame structure, take it 100 kg, take it 100 kg, take it 100 kg. In all these three cases, if all the dimensions are same, if all the weights are same, all the dimension and all the weight, right? Weight of the material used, the quality of the material used. If the material used is same, dimension, overall length and width is same, and the weight of the material, it means the strength, everything is same, you will find out the torsional rigidity, resistance to torsion of a space frame structure would be very much higher than any other design. Or simply I could say the torsional rigidity provided by ladder frame structure having a weight of 100 kg, the same torsional rigidity can be provided by a space frame structure having a much lesser weight. Take it 50 kg for reference. Much lesser weight. It means a space frame also reduces your weight. All the members are in tension or in compression. The complete load is going to be shifted together with the other parts. Got this thing? Okay, so whenever we design our vehicle, we have to consider this thing. Whenever you are going to design your chassis frame structure, I am going to summarize all the things that we have studied till now. Whenever we have to start designing our chassis frame structure, first work on the spaces and dimensions. Okay, now spaces and dimensions means the location of centroid and center of gravity. Now again, in the area moment of inertia, to have higher value of area moment of inertia, the first moment of area, or better, this is the second moment of area basically. If I talk about the first moment of area, we will find out the centroidal location. All the masses has got a relation with the centroidal location. The weight has to be balanced while considering the centroidal location. Weight has to be balanced as per the centroidal location, or better I would say considering the centroidal location. It means your CG and centroidal location should have to be in the same vicinity, in the nearest vicinity. Now again, spaces and dimensions, we are again into this thing, the area moment of inertia. Now you have to calculate the bending loads of each and every component that is being accompanied in your vehicle, right? Bending load. Divide your vehicle into as many compartments as possible. Then comes the moment of inertia. Your wheelbase and your track width plays a very crucial role in the performance of a chassis frame. Your wheelbase and your track width plays a very crucial role in the performance of the chassis frame structure. Make a matrix of stiffness and strength. Stiffness and strength. I am simplifying these things for you. Matrix of stiffness and strength of individual material for the members that you are using and your frame, right? 1. Make the matrix for wheelbase and track width in relation with the polar moment of inertia and mass moment of inertia. Polar moment of inertia and mass moment of inertia. At different values, you can find out the value or the relationship between these two things. Now, if we would be able to figure out these matrices, we can at least get a bit of idea how stiff, how rigid, or what is the strength of my chassis frame structure with the specific wheelbase or track width. Now, I told you about this bending load, right? For the bending load, if we are dealing with the space frame structure, all the components will be triangulated. Right? Okay. If I could give you an example, of the triangulation, it's about consider your frame structure as a beam, right? Once consider your space frame structure as a beam, a simply supported beam. Here I am having a solid rod. Take it, they are 100 feet apart. It's easy to say this, 100 feet. Okay, a solid bar, 100 feet apart, having a very heavy weight, or it's made up of steel, like mild steel. I applied a load of, take it, 1000 Newton. And I have witnessed flex. Take it, gamma. Right? Take it, gamma. If I would replace this bar with hollow tubes, at this position I am applying the load now. I have provided the support. This complete geometry is made up of hollow tubes. This is the triangulation. You will find out the flex in this diagram would be very less in comparison to the flex in the solid bar that I have used. Right? Triangulation is very important. So all the places where you are having the masses, the place where your driver is going to be seated, where you are going to mount your engine, your steering or anything, and those places you have to provide the triangulated parts. Triangulated parts, you have to provide the support in such a manner that the tension and compression forces will be distributed in the optimum ways. We can optimize the distribution of tensile and the compressive forces. Now again, your wheelbase, your track width, your overall length and your overall width has got a very important relation. Very important relation. With the wheelbase and track width, we have found out like these are the simple supports, where all the forces are going to be acted upon. These are the reactions to the ground. These are the reactions of the vehicle to the ground. But what about the overall length and overall width? Overall length and overall width also carries the movement. If there is any force or any load, carried away from the, like if this is my vehicle, right? If all the weight, all the masses are accompanied inside it, it's very easy to calculate this thing. Like we have already calculated, we can all calculate. But what if the mass is being accompanied here? What if the mass is being cargoed here? Right? What if the height of this mass is lower? What if the height of this mass is lower? Now, these two parts will start to create the movement inside the vehicle. And just make sure if there is a force away from the neutral axis, this is my lateral axis, and there is a load away from this, very far away from the neutral axis, its impact on the neutral axis stability will be higher in comparison to the load that is nearer to the centroid or the center of gravity location. So at one point, with the performance criteria, we need our wheelbase to be as long as possible so that the tipping of the vehicle can be reduced. But all the other things says the mass should have to be sustained, the force, the load should have to be sustained all together to the nearest vicinity of the centroidal location. In the next video we will be discussing about the performance of the vehicle, considering the wheelbase, track width, overall length and overall width. And tomorrow we will summarize the complete design of the chassis frame structure, where we will get to know how to decide the optimum wheelbase, track width, overall length or overall width for a vehicle. Okay guys, so now for any of the doubts you can follow us on Achilles Racing Club. ACHILLESRACINGCLUB. Find us on facebook.com/Achilles Racing Club. Find us on Achilles Racing Club. Follow our Instagram page. Very soon we will be uploading the short videos and the theoretical videos or the theories behind the design of the race car. Right? So if you have got any of the doubt, please write to us on Facebook, Achilles Racing Club. Okay guys, thank you so much.